Alright, today's video is on 4.5, and it's your last learning target in this unit. We're doing a different kind of video today because I'm having technical difficulties, so we're going to use a camera instead of my normal laptop. So this learning target kind of takes everything we've learned from the last 4 learning targets and kind of combines it into a purpose. So we use graphs to tell stories. We use graphs to get data and look at patterns and see things that are interesting. So in this learning target, you're going to get a lot of graphs that describe certain situations, and we're going to try and get as much data as we can from that graph. So I'm going to start off with a story. This is a story about Tom. Okay, here we go. Every morning, Tom walks along a straight road from his home to a bus stop, a distance of 160 meters. This graph shows his journey on one day. So this graph is showing that as time goes on, he is moving away from home. So distance from home, and then how long it's taking him to get away from home. That's what this graph is showing. Okay, but what does all this mean? This up, down, and then a straight line, like what's going on here? So we're going to use all the stuff we've learned from this unit to kind of figure that out. Okay, so first of all, is this graph a function, and how do you know? So there are a couple things to think about when it's a function. We know there's 2 things to think about. There's the vertical line test, and there's also thinking about every input has one output. If I draw like a single line through any point on this graph, then I am going to definitely only hit one point. So no matter where I draw my line, I only hit one point. So that tells me that it is a function, and it is a function because one reason it passes the vertical line test. Okay. The other reason I know this is because when I look at like the number 10, it only has 1 point here. When I look at number 20, it only has 1 point here at 40. So another thing you can say is that each input has one output. Okay. Next question, is this a continuous or a discrete function? So this is something we have talked about a lot, continuous versus discrete. This graph is definitely continuous because all my points are connected. There's no place on this graph where I just have a point standing alone, like this. That's discrete if I just had some random point there, but I don't. So this particular graph is continuous. And again, why? Because all points are connected. I'm trying to write dark so you guys can see it. Okay. Now, the domain range is something some of us struggled with in the last learning target, or the learning target before it, and so it's coming back now to haunt us. So remember, domain is always that, and I'm going to draw a little arrow guy, it's always left to right. And range is always that up and down. So I'm always going to want both notations. So domain, you're looking for that farthest left point. So if I look, and let me erase these lines here. I'm used to my thing where I can just click a button and erase, and now I have to like use my hands here. So farthest left point is right here. Like that's where my graph goes farthest to the right. I'm sorry, to the left. Then my farthest right point is way over here. So these two make it a little bit darker. That's my farthest left and my farthest right. The x value here on where the graph starts is 0. So this graph starts at 0 and it ends all the way over here. The x value is matching up to 120. The cool part now about the domain is now because the domain is time, I know that his journey started at 0, because all journeys do, and it goes all the way up to 120 seconds. So his journey lasted 2 minutes. You guys ask me all the time why domain is important. Well, here I can read from 0 to 120 seconds is his time that he spends. The other notation that I want is this inequality notation. Range is now the opposite thing, right? It's the up and down, and range is that distance from home. Range is that y value. So the range, the bottom point is still this guy right here. It's just they share it on the left and the bottom. So that means that my range also starts at 0. My range for the top is also this point here. Same point. However, we are now looking to go over to this value because we want the y. We want the distance from home. We want that value. So in this case, your very, very top point on the top of this graph is 160. Remember that range in this case doesn't represent the time, it's distance. So when I look at this range, I'm saying, okay, he started at 0, which means he's at home. If you're at 0 distance from home, you're in your house. And he ends up being 160 meters away from his house. So he's covered that amount of distance in his journey. So it is like a foreign language. When you look at this notation, you kind of have to look at what it means. Like if I were to cover this graph up and tell you to read what this domain means, and I tell you it's time, you should be able to tell me a story about that time without seeing the graph. Independent variable is always the same as the domain, so it's time, it's your input, and the dependent variable is your distance. The distance he goes depends on the time, what time he's at. So depending on the time, he is at a certain distance. Okay. The next question says f of 50. So remember, this is function notation. This takes us back to, I think, 4.3. And in function notation, this guy here is your x. So this question is basically asking for your y. So if I go to my graph, and I'm trying to move this up, but it's kind of hard to not have the graph showing while I'm moving that up. If I go up to the graph and I look for f of 50, there's f of 50 right here. Okay, there's x that's 50. Right there is x. So now if I want to find the matching y value, I just take my pencil and go up to the matching y value, and then that's at 100. So the f of 50 is 100. Okay, we did this in 5.3, so that should be familiar. The next question says, what does this mean in the context of the story? If I know that 50 represents my time, and I know that 100 represents my distance, then when I want to say this out loud in English, I could say f of 50 equals 100, but if I want to describe this to someone in terms of what those numbers mean, I would want to say something like, at 50 seconds, he is 100 meters from home. Again, we're translating a foreign language. I want these numbers to have meaning. I want them to have an English description with them. Okay, and that's what this learning target is about, is assigning meaning to all this. All right, the next question says, if f of t equals 100, what is the value of t? So this is the opposite kind of question we saw in f of 3. Now it's saying that this guy, actually it's worded a different way. This guy is like your x, right? But we don't know what it is, but we do know that y is 100. So if I know that y now is 100, I'm going to go back to my graph, and I'm going to go to where I know y is 100, which is right there. That's where y is 100. And I want to find out what all the values of x are there. So I'm going to kind of make my line here and see where it crosses it. It crossed it here, and it crossed about here. Now, it's okay that it crossed here. Now, you guys freak out when it's not like on a grid line, but it won't always be on a grid line. So this question is basically saying when y is 100, x is both 50 and x is both about 85. So when I answer this question of what is the value of t, sorry, I'm getting used to this camera here, it's weird. I'm going to say that t equals 50 and t equals 85. Right? That's what we just talked about. The 50 and the 85 connected the 100. It's a lot to think about. Okay, now what does this mean? This means that at both 50 and 85, he's 100 meters from home. So at 50 seconds and 85 seconds, he is, it only has one S. He is 100 meters from home. Okay? The next question, why would f of 100 equal f of 120? So remember, this is your x value, and this is also an x value. So this is kind of basically asking you, go look at where x is 100 and 120. So let's go look. So when I look at where x is 100 and 120, that's right here, and that's right here. And when I connect those up, notice that they both are on this straight line. They both equal 160. So at 100 seconds and 120 seconds, he's at 160 still. So this is interesting because I want to answer this question technically. Why would f of 100 equal 120? They both are at 160. The implication of this is quite important. The implication of this is saying that at the same time, at two different times, he's at the same place. That's okay. It just means that he was probably standing still. When you're standing still and time goes by, your distance doesn't change, right? This is saying, like, look, at 100 seconds, he's 160, then at 110, he's 160, so at 120, he's at 160. So as time is moving forward, his distance is not changing. So he's probably standing still. I'm going to put this like this. This is on your next page of your notes, so just so you're aware what I'm pulling up right here, you have to turn move your packet over. Okay. Does this graph mean he's going up a hill? That is such a big no. Just because the lines go up and down does not mean graphs represent hills. This graph represents distance from home, not height. What could have happened if this is like what all this information, we know where he's at certain times, we know the time he's gone, we know the distance he's gone. What is the story here of Tom? Like if I were to describe the whole thing from start to finish of what Tom is doing, how I would describe this. Well, what I would say is that he started at home. So he left home, walking to the bus stop, right? That's where he's going. And that's this portion right here. That's him walking to the bus stop. At some point right here, he goes back. He goes back towards home because the distance is getting smaller, so he's headed back towards home. And maybe he went back to pick up he dropped his headphones. So at this point, he's gone back, he's picked up his headphones, and then because this graph is steeper, do you see how it's like steeper than this line right here? That means that he's moving faster. He's covering more distance in a shorter time. So he probably realized he was late. And ran to the bus stop. At which point he then waited for the bus to come. Okay. So your goal in this learning target is to be able to come up with these stories from these graphs and create graphs from these stories, while all at the same time remembering all of this stuff that we have learned from your previous learning targets in this unit. Before you do practice, however, you need to take a look in your notes. You've got this thing labeled activity. Do not move on before completing it. I need you to come see me to get the required materials and the directions. So do not do the practice before you have done that. Okay? All right. I think this learning target's fun. I hope you enjoy it. It's actually kind of cool putting it all together.